Hey everybody, in this video we're going to go through modeling and verifying differential equations, which is section 7.1 and 7.2. Our essential question is how can we interpret and verify differential equations and their solutions. So on your guided notes, take a second and pause the video. I want you to try this warm up. Given that k is a constant, what is the fourth derivative of y? All right, so y is k sine of 5x plus 2 cosine of 4x. K being a constant means it's just a number. So the first derivative is going to be derivative of sine is cosine. Copy and paste the inside times the derivative of the inside, which is going to be 5, times the k that's out here in front. So this is going to be 5k cosine of 5x. Derivative of cosine is negative sine. Copy and paste the inside times the derivative of the inside, which is 4. 4 times 2 is going to be 8. So there's my first derivative. Now we're going to take the next derivative to get the second derivative. Here in this one, derivative of cosine is going to be negative sine. Copy and paste the inside times the derivative of the inside, which is 5. So 5 times 5 is going to be negative 25k sine of 5x minus derivative of sine is cosine 4x times the derivative of the inside, which is going to be 4. So 32 is going to go out here, 4 times 8. All right, let's keep going. Here's the next one. We're going to go with third derivative. Derivative of sine is cosine of 5x times the derivative of the inside, which is going to be 5. So 5 times 5 is 125. So negative 125k. Derivative of cosine is negative sine. So this is going to turn to a positive. Sine of 4x times the derivative of 4, so 32 times 4 is 128. All right, finally, last one. Fourth derivative. So derivative of cosine is negative sine, so this is going to turn to a positive. Sine of 5x, 125 times 5 is going to be 625k. Sine of 5x. Derivative of sine is cosine, so plus cosine of 4x times the derivative of the inside, which is 4. 128 times 4 is going to give me 512. So there's our fourth derivative, with k being a constant. Okay, let's get going here then on our notes for 7.1 and 7.2. I realize this is on here and I didn't talk about it at all. It says the quiz here is going to be on Friday. We're going to have to move that with having off yesterday from the cold day and me being gone today. So we'll figure out a new time for this quiz. I'll tell you about it tomorrow. All right, so we're going to talk about a differential equation. When we talk about differential equations, there means it's an equation that's an x, y, and it also involves somewhere about the derivative of y. So I like to think about this a lot at like implicit differentiation when we took the derivative in terms of x's and y's, and that first line that we got to, that reminds me of what our differential equation is going to look like. So here are some examples of differential equations, and you can see for each one there is an x, a y, and a y prime. Oh, this one has a y, y prime, and y double prime. No x in that one, but sometimes there is an x as well. Here's the same thing, just written with f of x, f prime of x, and f double prime. And then here's it's written as dy dx with the y, dy dx, and second derivative. All right, and we're going to be looking at solutions today to those differential equations. Those solutions, when you take their derivative and their second derivative, they work in this differential equation, meaning they make this a true statement. There could be multiple different solutions, and so that's what we're going to kind of look at today as we verify those different solutions. All right, here we go. Number one. So we want to determine whether the given function is a solution to this differential equation where we have f double prime of x minus f of x, and we want them to cancel out to equal 0. So the first thing we have to do is we have to get to this second derivative. So we're going to go ahead with the first one, and we're going to get to the second derivative. So it's going to be f prime of x. Derivative of sine is cosine. And then we get to the second derivative, and the second derivative of cosine is negative sine x. And we want to see, does this work in this differential equation? So what we're going to do is we're going to go right to this differential equation. We're going to start filling everything in. This one says f double prime of x minus f of x. So f double prime of x is negative sine x minus, because that's what the differential equation says, f of x minus sine x. And we want that to equal 0 if this is true. And as I go ahead and look at this, well, this is negative sine minus sine. So this is negative 2 sine x equals 0. And that's not true. So this is determine whether each function is a solution. No, this is not a solution. All right, let's try the next one. We're going to go back through and find all the derivatives right away. So here's the first derivative, which is going to be, okay, the derivative of e to the x is itself times the derivative of the exponent. So the first derivative is going to be negative 4e to the negative x. Then the second derivative, again, e to the x is itself times the derivative of the exponent, negative 1, which is going to make that front number positive 4 now. So that as I plug it into this differential equation as my second derivative minus my function, that should equal 0. So my second derivative is 4e to the negative x minus my function, which is also 4e to the negative x. Question is, does that equal 0? And yes, it does. As we subtract those two, those are exactly the same. So 0 equals 0. Why don't you pause the video and try C on your own, and then we're going to go through it together. Okay, first derivative, c e to the x. Well, that's e to the x is itself times the derivative of the exponent is just 1, so that's going to be c e to the x. And as we take the derivative of that, oh, it's going to stay the same because e to the x is itself times the derivative of the exponent is 1, so it's going to be c e to the x. So I take my second derivative and I subtract my function, and I'm seeing if that equals 0, which they will, so 0 equals 0. So yes, this is a solution. All right, here's one more in the same way as we are looking at them. We're trying to determine if the function is a solution, but now we have a new differential equation. So dy dx, as we are looking at that, that means derivative. So my dy dx, in this case, is going to be 4. So as I plug everything in, I'm going to say, is 4 equal to, okay, 4y is this part over here over x. Well, 4y is going to be 4 of my y's. My y's are also 4x over x, the original. And so I think there's too many 4s in this one. This is going to give me 4 on this left-hand side, but on the right-hand side, I'm going to have 16x over x. X's will cancel, and 4 does not equal 16. So no, this is not a solution. Okay, let's try it with the next one. dy dx is equal to 4x cubed. So dy dx, 4x cubed, does that equal 4 of my y's over x? Oh, this one's going to work out, I think, here. 4x cubed is on the left. On the right here, the x's are going to cancel, making it 1 less in the numerator, which is going to be 4x cubed. And that is true. 4x cubed equals 4x cubed. So yes, this is a function. A solution, I'm sorry. All right, in this one, we want to solve for a value of k. So we're looking for that answer for k, but this is going to be a solution of this differential equation. Okay, so the first thing that we're going to do is we're going to go through and we're going to find everything we need. We need a y and we need a y double prime. So my y prime is going to be e to the 2x times the derivative of the exponent, which is 2. Then in the next one, we're going to go e to the negative 3x times the derivative of that exponent, which is going to be negative 3. So that out in front here, this is going to be negative 3k. Now let's go second derivative. E to the 2x times the derivative of the exponent, which is 2, so 4 out in front. Here, this is going to be itself e to the negative 3x times negative 3, which is going to make this plus 9k. All right, let's start filling everything into this differential equation because we want it to be a solution here. So we're going to go 4 times y, which was e to the 2x plus k e to the negative 3x, minus my second derivative. We're going to subtract the whole thing, so I'm going to put parentheses around it so I distribute my negative. 4 e to the 2x plus 9 ke to the negative 3x. So I'm kind of running out of room. And that needs to equal my 10e to the negative 3x. All right, so let's start to simplify this. I'm going to start by distributing out the 4. So 4e to the 2x plus 4k e to the negative 3x. Distribute out the negative. Minus 4e to the 2x minus 9k e to the negative 3x equals 10e to the negative 3x. Now we start to simplify. Okay, the 4e to the 2x minus 4e to the 2x, that's going to cancel. And then these are like terms as we are looking at them here, so we can combine those together. That's going to give me negative 5 k e to the negative 3x equals 10e to the negative 3x. Now, they both have the same variable on these that we are looking for, so we really don't need this e to the negative 3x, and we're just going to solve for k so we have the same coefficients. So I have negative 5k equals 10, so k equals negative 2. All right, last one that we're going to end up doing here. Is right here. Okay, so a curve has a slope of 2x plus 3. So the slope we know is the derivative. So that's my dy dx is going to be 2x plus 3. All right, and then as we look at these, 2x plus 3, well, the derivative, dy dx, this is not going to be the derivative of that. Neither is b. That's not going to give me a derivative of 2x plus 3. But I have c could give me 2x plus 3 as my derivative, and so could d. And as I look at e is not going to give me that derivative of 2x plus 3. All right, which of the following is an equation for this curve if it passes through the point 1, 2? Okay, so then on the actual curve, it needs to go through the value of 1, 2. So let's just plug in for c. Let's just plug in 1 for x, and it should equal 2. So that's going to give me 1 squared plus 3, and that does not give me 2. That gives me 4, so c is out. So then let's try d. It should equal 2. We're going to end up with 1 squared is 1 plus 3 minus 2. And that gives me 4 minus 2, which equals 2. Perfect. So d is the one that would give me the slope or the derivative of 2x plus 3 and pass through the point 1, 2. All right, you're going to get started on your homework, the 7.2 worksheet. I will have a video going through those homework questions as well.